Let's look at this problem. Let A, B, C, D, E, F be an equiangular hexagon. The lines A, B, C, D, and E, F determine a triangle with area 192 times square root 3, and the lines B, C, D, E, F, A determine a triangle with area 324 times square root 3. The perimeter of hexagon ABCDEF can be expressed in this format: m plus n times square root p, where m, n, and p are positive integers and p is not divisible by the square of any prime. What is m plus n plus p? This geometry problem is actually very standard. It normally depends on how you draw this diagram. And for me, because I have a habit to draw any equiangular hexagon or a regular hexagon in this way, I always draw a equilateral triangle. And this is what I always do. I always draw an equilateral triangle, and then draw 3 parallel lines to cut this triangle so as to form an equiangular hexagon or a regular hexagon. This is what I do. I draw a parallel line in here, which is parallel to this line, right? And another parallel line in here, and the same thing in here. So this gives us either a regular hexagon or an equiangular hexagon, right? Because for an equilateral triangle, this is 60 degrees. Therefore, this is 120 degrees. And the same thing for each of these inner angles, right? Therefore, by definition, we have an equiangular hexagon already. So if we start from there, we should understand that this triangle is actually an equilateral triangle, and the same for this triangle, right? So let's mark the vertices. So let's say this is A, B, C, D, E, F. Okay, and A, B, C, D, E, F forms a triangle with this area. So the first triangle is just this. So let's call this x1, y1, and the z1, right? And the other triangle is this. Let's extend BC. We extend this line, BC, DE, and AF. This certainly forms another equilateral triangle. Let's call this x2, y2, and z2. And the question is that given the area of these two equilateral triangles, can we derive the perimeter of this equiangular hexagon? The answer is yes. And as long as we can derive the side lengths of each of these equilateral triangle, then we are pretty much done, right? Because we know that this, I'll use a different color, this is also an equilateral triangle. Therefore, this side equals this side. And the same thing for this, right? So we have all these equilateral triangles, and I'll use a different color. So this is an equilateral triangle, right? Therefore, if we know the side length of x1, z1, for example, then that is equivalent to this length. Right? So this is our analysis. So now let's start the calculation. Now for a given equilateral triangle, if we know the area, let's say I draw this equilateral triangle here. For this equilateral triangle with a side length of A, and we know that the half side length is a half of A, right? And this is the height. At the same time, we know that the height is square root 3 over 2 times A, right? This is 30 degree, this is 60 degree. So it's very easy to calculate this length. You can either use the Pythagorean theorem or use the trigonometry. All right, then the area of this equilateral triangle equals a half times the height, which is square root 3 over 2 times A, then times the length of the base, right? That's A. So this equals square root 3 over 4 times A squared. Good. Then we can compare this formula with these two numbers. Then it's quite straightforward to get the side length of these two equilateral triangles. Now let's do it one by one. When 192 times square root 3 equals square root 3 over 4 times A squared, we can cancel these two square root 3. Then A squared equals 4 times 192. So 4 is 2 squared, right? 192, what is that? So we can get a factor of 4 out. So that's another 2 squared. And then times 48, right? Then we have another factor of 16 in this 48, right? So that equals 2 squared times 2 squared times 4 squared. That's 16 times 3. Therefore, we know that A equals 2 times 2 times 4 times square root 3, which equals 16 times square root 3. Then we can do the same with this 324 times square root 3. So that's 324 square root 3 equals square root 3 over 4 times, let's call this B squared. And then we cancel these two square root 3's. We have B squared equals 4 times, that's 2 squared, times 324. And this equals what? We can still factor a 4 out. So that's 2 squared times another 2 squared times 81, right? And 81 is 9 squared. So it's a 2 squared times 2 squared times 9 squared. Therefore, B equals 2 times 2 times 9, which equals 36. Now let's look at this picture. So let's say x1, z1 equals 16 times square root 3. If that's the case, as we pointed out, that this side plus this side and plus this side shall equal this side, right? The side x1, z1. Therefore, these three sides of the equiangular hexagon have a sum of lengths 16 times square root 3. Then let's look at the triangle x2, y2, and z2. We know that this part, the x2, z2 equals 36, right? And this part, I'll use a different color. I'll use a red color. So this length certainly equals this part, this length and this length, right? So that is 36. Therefore, the perimeter of this hexagon just equals x1, z1 plus x2, z2, which equals 36 plus 16 times 3. And if we compare this format with this result, we'll know that m equals 36 and the n equals 16 and the p equals 3. Therefore, the sum equals 52 plus 3 equals 55. Therefore, C is our choice. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.